So in this video we're going to go into part D of this first problem. It says the cost of cooling the house accumulates at the rate of 5 cents per hour for each degree that the outside temperature exceeds 78 degrees Fahrenheit. What was the total cost to the nearest cent to cool the house for this 24-hour period? Well, it's obvious we're only going to cool the house when it gets to be hotter than 78 degrees. And so we're only going to cool the house within the interval that we just identified between t is equal to 5.231 and t is equal to 18.769. In that interval, the temperature rises to 78 degrees or above, and so we want to turn on the air conditioner, and it's going to cost 5 cents per hour for each degree that the outside temperature exceeds 78 degrees. So I've shaded in the area between 78 degrees in the curve, and that's really what we're looking for there. The area under this curve has units of degree Fahrenheit, or Fahrenheit degree hours, or we could just say degree hours. That's kind of a funny unit of measure that we're not used to working with, but that's exactly what it is, because it's a product of hours times degrees, so we're going to call it degree hours. And that's precisely what we're paying for, 5 cents per hour per degree. Now it's not degrees per hour or hours per degree, it's degree hours. That's what we're paying for. So we want to find the area between 78 and the blue curve there, and that area is going to be the number of degree hours that we need to pay 5 cents, for each of which we need to pay 5 cents. And how do we find that area? We don't want the integral from 6 to 1, the integral from a to b. It's not only going to give us from 78 and above, it's going to give us everything from under the curve from 5.231 to 18.769. And what we want to separate out there is this rectangular shaped area from 6 to 18, or with a base of 12, times 78. And from our calculator, 12 times 78 is 936. So that is going to give us the number of degree hours that we have to pay for, and we're simply going to multiply that by 0.05. And so, as I said, before I can answer the question, I need to write down the calculus expression that yields the answer, and then that's all I need to do. I can simply write the answer at that point. So that's for part D. So what we need to do, we have a and b stored in our calculator, and we need to find the integral from a to b of f of t dt. So I'm going to bring up the calculator, and I'm going to go back to my graph, and the 78, yeah, it's important here. I'm going to do second calc number 7 for integration. My lower limit, all I have to do now is type in alpha a, enter. My upper limit, alpha b, enter, and it's going to give me the area under the curve being 1157.9118. From that I want to subtract, so I can just hit the minus, and it'll give me answer minus 936. And that comes out to be 221.911, and I want to multiply that by 0.05, and giving me $11.10. Rounded to the nearest cent is what we were asked to do there. And so we found the integral under the whole area under the curve from a to b. We subtracted out the rectangular area, 12 times 78, which is 936, and so we ended up with, and multiply that by 5 cents, so we end up with $11.10. And again, that's all that I would need to write for part D. 0.05 times the quantity integral from a to b f of t dt minus 936. Making sure that a and b are clearly labeled somewhere on your paper, and that capital F of t is also labeled, which it is. And so that brings us to the end of problem 1.